Welcome to our first lesson for 3D shapes. So lesson 1 is going to be on area and perimeter. Before you even start this though, make sure you have your formula sheet printed out so that you're not going to have to spend too much time looking up the formulas you need for solving these problems. Another point to make on all of these ones, it's really good practice to draw a picture. If they don't give you a picture, draw a picture. It'll really help you visualize what's going on. Okay. This one's going to take a while for me to go through them all. I'm going to go through it in lots of detail. So if you need to skip ahead to another question, you can either look in the description of the video below and go to the next question, or just scooch ahead or speed me up. Question 1. Find the area, so we're going to be looking for the area of an equilateral triangle of side length 6 centimeters. So just a reminder, equilateral is all sides equal. So if we were drawing that, a rough sketch would be 6 and 6 and 6 all the way across. But to find the area of a triangle, that's base times height divided by 2. So we're going to have to find the height of this triangle from one corner to the opposite side at a right angle. That's going to be our height. And we might not be able to see exactly how to find it right away. But if instead we look at this smaller triangle that I've highlighted in purple, that's a right angle triangle, and we can use the Pythagorean theorem on it. And we would know that this base of that purple triangle is 3. The height is h, and then the hypotenuse is 6. So I could write 3 squared plus h squared equals 6 squared. So h squared equals 36 minus that 3 squared, which was 9. So h squared equals 27. And then we're going to take the square root of both sides. Or we could leave it as a root and simplify it. We would get that h equals 5.2 units. Or we could simplify it to 3 root 3. Both of those are going to be same value. And then to find the area, we go back up to the equation that was in blue. So the base of the whole triangle, because not just the purple one, the base of the whole big triangle was 6 units. The height, we just figured out, was 5.2, or 6 times 3 root 3, either way. Divided by 2 for both of those options. And when we do it with a decimal, we get 15.6. There were no units given, so I'm going to write units squared. If we do it as a square root, we're going to get 9 root 3 units squared. So it's going to be really important for you to remember your units. And if units aren't given in the question, then you just write literally the word units at the end. Example 2. Question 2, sorry. Find the area of a regular hexagon of side L equals 6. So that means every single one of these sides is 6. Then there's a hint. A regular hexagon can be divided into equilateral triangles. And so we can divide it in equilateral triangles. If we take all the diagonals and go across, we're going to get 6 equilateral triangles. And because they're equilateral triangles, I know that that's 6. That's 6. Every single thing in there is 6. So basically, we have a triangle that has side length 6. We could find the area of one of those slices, one of those triangle shapes, and then we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 of those triangles. So to be 6 times whatever a triangle is going to give us our total area. Well, we happen to figure out just in the question above that the area of this thing is 15.6 or 9 root 3 units squared. So the area of my hexagon is going to equal 6 times 15.6, or 6 times 9 root 3. And either way, when we do it, it'd be 93.53 units squared, or it would be 54 root 3 units squared, the area of the hexagon. Question 3. Find the area of a trapezoid ABCD with BC parallel to AD. That's what those symbols mean. AB equals 5, blah, all the other things. So I'm going to draw ABCD. So A, B, C, D. Well, I know that BC is parallel to AD. Use that. AB is 5. CD is 5. BC is 6. AD is 12. So to find the, I'm going to write it in a different color, the formula to find the area of a trapezoid, it's going to be a half of A plus B times the height. But we don't know what the height is. So I'm going to draw little lines down. That would show me what the height is, right? And I'm going to use that purple again. In that triangle there, if we were to draw it outside again, H5, we need to figure out how much this bottom part is from A across to where the height. But because the two slanty sides are both 5, we can see it's symmetric. And because 6 got used up down at the bottom, so if I was to use yellow in here, if it's 6 at the top, then it's 6 at the bottom. 12 take away 6 mean we'd have 6 left over. So like this part plus this part have to be a total of 6 centimeters or whatever units. That means each one would be 3 units big. Okay, so we have a right triangle where the bottom's 3, the hypotenuse is 5, and the height is, we don't know. So it's going to be 3 squared plus h squared equals 5 squared. H squared equals 25 minus 9. H squared equals 16. Square root both sides. We get that the height is 4. So we now have our trapezoid where the height is 4. So we can substitute for all of these. Our height is 4. A is the top of the trapezoid, so that's 6. B is 12. And when we substitute in, we'll have half of 6 plus 12 times the height was 4. So that's going to be half of 18 times 4. So that's 9 times 4, which is 36. And I was wrong. It wasn't centimeters. It's just regular old units squared. Question 4. A wire 58 units long is bent into the symmetrical arrow shapes shown. Find the value of y. Anytime you see any sort of questions that has a wire that's bent into a shape, that question is talking about perimeter. So when we add up all the sides, it's going to add up to 58. The other thing that they told us in this question is they said it was symmetrical. And the fact that it's symmetrical means that y plus 7 will be the top of both of those. This little guy there is going to be y. Y plus 4 is going to be the upright thing. So the perimeter is going to equal, I'm going to start right here and go clockwise around. It would be y plus 4 plus y plus 7 plus y plus 7 plus y plus y plus 4. Across the bottom is y plus 1. And altogether, this whole thing equals 58. So 58 is going to equal, I'm going to count up all my y's. 1, 2, 3, 4, 5, 6, 7. So I've got 7 y's, and then 4 and 7 is 11, 18, 22, 23. So 7y plus 23. I'm going to bring the 23 over to the right side. So 58 minus 23 equals 7y. That gives me 35 equals 7y. Divide both sides by 7. I get y equals 5. This question didn't have units other than units, so I get that y equals 5 units. Question 5. Okay. Trapezoid has an area of 24 centimeters, perimeter of 20 centimeters. So I'm going to draw a little trapezoid, and it has an area of 24 centimeters squared, a perimeter of 20 centimeters squared. It says then that the lengths are all times by 3, and it gets a lot bigger. Lengths are multiplied by 3. And if you remember back from the ratios part, or if we just think about common sense, whatever the values were, they're going to be now 3 times as much. So if you made up any numbers that add up to 20, the perimeter of the big one is going to equal 20 times 3. So that's going to be 60 centimeters. That's going to be the perimeter of the big one. When we're dealing with area, I hope you remember that the area of, remember we did the thing, if we had a square and it was 2 by 2, so its area is 4. If I triple all the sides, that would give me a square that's 6 by 6. That goes to 36. So when the sides were times 3, when we do the area was times 9, or times that scaling factor squared. We did it with those pink questions in the statue and things like that. So we know that if we had the sides and the ratio was 1 to 3, the area would be 1 to 9 because we're going to square them. So the small one and the big one. So we know that the area of the small one was 24. The area of the big one, we're going to have to figure it out. It's going to be times 9. So the area of the big is going to be 24 times 9, which is 216. And there were units, and area is in centimeters squared. Question 5. In question 5, they want us to find the area of the shaded region. So for this one, area of the shaded region is going to be the area of a semicircle, and then subtract away from it the area of the triangle. So the area of a semicircle is going to be pi times r squared over 2, minus the area of a triangle is going to be base times height over 2. So let's stop and see if we can figure out what these things are. So the radius in this circle would start in the middle and go over to the side. So if we were to look all the way across, it would be r plus r. So all the way across the diameter would be 2 times r. So that makes sense. And the reason I did that, because in the triangle, it's a right-angled triangle. And they told us that AB is 8, BC is 6. So basically, we have a right triangle where the base is 6, the height is 8, and they want us to find, not squared, the hypotenuse. And that hypotenuse is going to equal 2 times the radius. So we could do 6 squared plus 8 squared, Pythagorean theorem it up. 6 squared plus a squared equals h squared, so 36 plus 64, so 100 equals h squared. Square root of 5 both sides. Take the square root of both sides, and we get that h equals 10. So if all the way across this whole thing is 10, that means that my radius is going to be half that, or 5. So we know that the radius of the semicircle is 5. So I'm going to use that pi times 5 squared over 2 minus. So looking at the triangle, we need the base and the height. Base and the height of a triangle always meet at right angles. So in this case, the base is going to be 6. The height is going to be 8. Even though it's weird and it's not sitting on its base, the base and the height are the two sides that meet at right angles. So that's going to be super, super, super important. I'm going to add some pink, green and pink. That's the base and the height because they meet at a right angle divided by 2. So when we sub in 3.14 and we do all that, I get 39.25 minus 6 times 8 is 48 divided by is 24. So I get 15.25. If you leave it in terms of pi, you would have 12.5 pi minus 24. That doesn't look good. I'm going to write it down lower. The other way of doing this, if you left it as pi, would be 12.5 times pi minus 24. So either one of these is going to be equal to the area of the shaded shape. One is more precise because pi is not an exact number, but the decimal is pretty close as well. Question 7. Add a canning plant. Orange juice cans with a base area of 78.54. Okay, so I'm going to highlight that. The cans have a base area of 78.54, are packed in boxes in 4 rows of 3. Find the dimensions of the base of a box that can hold the 12 cans. Draw a picture. Well, yes, we will draw a picture. So I am going to draw a box. No, that did not look. Actually, I'm going to draw a circle first. So if I got this circle, and then I want to duplicate it, and I'm going to make 1, 2, 3, and then I'm going to, can I collect all 3 of them? Let's see. Duplicate. And then I want to duplicate again. And then I want to duplicate again. Okay, so I have all of these circles inside a box that's got corners. So we've got all the circles inside a box. We know something about each circle. We know that each circle has, I'm going to draw a bigger one just to make my life easier. We know it's going to have a radius, and we know that the area of each circle is 78.54 centimeters squared. I can work backwards, though, to figure out what the radius is. So if I know that area equals pi times r squared, 78.54, that's the area, equals 3.14 times the radius squared. Divide both sides by 3.14. Happens to work out nicely that that's 25. So I get 25 equals the radius squared. Square root both sides. I get that the radius is 5 centimeters. So that's the first thing we're going to do to find out the dimensions of the box, because that's what we're looking to solve. We're trying to find the dimensions of the box. Oh, this is a top view. I should have mentioned that before. So in a top view, if we were looking at this, that's one radius, another radius, another radius, another radius, radius. Each circle is going to have 2 radiuses, so that the width of this box would be 6 radiuses big. And if we were to go and look at the length, I'm going to have 2 r's from there, another 2 r's across that circle, 2 r's across that one, 2 r's across that. My length of my box is going to be 8r. So when we're looking at our box, the box has dimensions of 6r by 8r. We know, though, that r is 5 centimeters, so it's going to be 6 times 5 centimeters by 8 times 5 centimeters. And when we multiply that, we get that it's 30 centimeters times 40 centimeters, and that's the dimensions of the base of the box. All right, question 8. Question 8, in the triangle ABC, AD and BE are two. Okay, I'm going to draw this because already I know I'm not going to be able to figure it out. So I've drawn a triangle, and I made sure it wasn't isosceles or anything like that because they didn't tell us it was isosceles. Oh, but I kind of draw it right angled, and I don't really want that. So let's do something that looks more like that. That's not a right angle. Okay, so if I call this A, B, and C, it says that AD is one altitude. Altitude is perpendicular to the opposite side. So AD, I'm going to draw from A down to the bottom, and it's not quite at a right angle, but there I think it is. Your picture does not need to be perfect. I'm just trying to be tidy. It tells us that A to D is 2. Then it says B to the other side is going to be another number. I'm going to use a different color. B going across to here. That looks pretty close to being a right angle there. It tells us that B to E. Oh, we're trying to find BE. Okay, we're trying to find BE. Okay, but it gives us some other lengths. It tells us that AD is 2, BC, this whole thing, is 6, AC is 4, and they want us to find the height. They want us to find, the altitude BE. Hint, express the area in 2 different ways. Okay. If we write the triangle ABC with its height of 2 and its base of 6, and I asked you what the area of that triangle was, you'd be like, okay, it's going to be base times height over 2, which is 2. Sorry, the base is 6. It won't matter. But 6 times 2 over 2. So the area of this triangle is 2 units squared. If I have the exact same triangle, but now I draw it this way with that 4, and that's a right angle, and that's or unknown, sorry, that's not 2. That's the part that we don't know. That's our BE. So it's the exact same triangle. It's still just ABC, but looking at it from another way, given that it's the same triangle, it's still going to have an area of 2. But now if we look at it from the other way where AC is the base would be 4. The height is, well, we don't know. That's what we're trying to find. So that's BE, and it's divided by 2. So now we want to get BE by itself. So first thing I'm going to do is get rid of the dividing by 2, bring it over to the other side. So 2 times 2 equals 4 times BE. So that gets 4 equals 4BE. I feel like I made a mistake here. Yes, I did. Apologies. That's divided by 2. That's supposed to be 6. That's 6. That's 6. Okay. Only because I knew what the answer was supposed to be. Divided by 2, so that's 6. That's 6. So that was 6. That was 6 there. So it's 6 times 2, that's 12. I still want BE by itself, so I'm going to divide both sides by 4. So when we do all of this, we get that BE equals 3 units. And the trick here was thinking about the triangle. The base doesn't have to be on the bottom. Okay, question 9A, the last question. A triangle ABC has an area of 24 centimeters. So I'm going to draw a triangle ABC. Oh, triangle ABC has an area of 24 areas. So area of ABC equals 24. M is the midpoint of BC. So I'm going to just estimate that midpoint. M is the midpoint of BC. Find the area of triangle. So I'm going to draw from here to here. And they want us to find the area of triangle AMB. And we knew that this was the midpoint of that. So, I mean, we can all probably intuitively guess that we're going to take that area and divide it by 2, but it wants us to justify our answer. So here's how I would justify the answer. That's going to be the height. And that height would work for triangle ABM, but it also is going to be the height of triangle ABC. So it doesn't matter which triangle we're drawing. I'm going to draw them separately. If I have triangle ABC, that's going to be ABC. It's going to have that height of H. But also, if I were to draw, I'm going to draw it smaller over here. If I was to draw a triangle ABM, it still has that same height. So it really doesn't matter which triangle we're looking at. The heights of both of those are the same. But if we're looking at triangle ABC, so that's the green one, triangle ABC. The base, we don't know what it is. The height, we don't know what it is. So I'm going to call it H, but it's going to be X times H divided by 2. For triangle ABM, that's the pink triangle. We know here, so if that whole thing was X all the way across, that's going to be X divided by 2. So it's going to be X divided by 2 times H over 2. If we rewrite that, we could write it as X times H over 2 with a divide by 2 at the end. It's the same thing, just with a slightly different order. We know that X times H over 2 happens to equal, oh, I didn't think it would do that. X times H over 2 happens to equal 24. So we have an X times H over 2 that happens to equal 24. So that's 24 divided by 2. So the area of triangle ABM is going to equal 12 centimeters squared. I hope that makes sense. And I used up all my space for part A. So that was all for part A. Part B said a triangle ABC has an area of 24. Okay, same as before. Now they've got it, though, where that P is the midpoint of AB. Okay, I'm going to sort of repurpose the second triangle that we drew. P is the midpoint of AB, and R is the midpoint of here, and now they want us to find the area of APR. So if we're going to find the area of APR, it's basically going to be that same thing we did before with the yellow box, except the 24, we cut one side in half and we cut the other side in half. And I'm going to write that out. So because we cut two sides in half, so divided by 2 times. And when we do that, we're going to get that that's going to be 6 centimeters squared. So APR equals 6 centimeters squared. Thanks for watching. Bye.